Have you ever gazed up at the night sky and felt a sense of wonder, mixed with a little bit of fear? The universe is vast, beautiful, but it holds secrets that are truly terrifying. Today we're journeying into the heart of one of its darkest mysteries, black holes. Not just any black holes, but the colossal monsters that lie in wait, ready to devour entire stars. Forget everything you think you know. These aren't just cosmic vacuum cleaners. They're gravitational tyrants, bending the very fabric of space-time to their will. When a star gets too close, it doesn't just vanish, it gets caught in a deadly dance, a process so violent it beggars belief. This is called a tidal disruption event, and it's one of the most spectacular and horrifying displays in the cosmos. Imagine a star, millions of miles across, a colossal ball of burning gas just like our own sun. As it drifts near a supermassive black hole, the gravitational pull becomes immense. But here's the terrifying part. The pull on the near side of the star is exponentially stronger than on the far side. This difference in force, the tidal force, begins to stretch the star. It's like pulling a piece of taffy. The star elongates, its spherical shape warping into a long, thin stream of stellar material. We call this process spaghettification, and it's as brutal as it sounds. The star is literally ripped apart, atom by atom, stretched into a cosmic noodle of plasma and gas. It's a death scene on a scale we can barely comprehend. What happens to all that stellar debris? Most of it gets pulled into what's called an accretion disk. This is a swirling, superheated whirlpool of matter spiraling around the black hole's event horizon, the point of no return. As the material spins faster and faster, friction heats it to millions of degrees, causing it to glow brighter than 100 billion stars combined. For a brief period, the black hole, an object defined by its darkness, becomes the center of one of the brightest light shows in the universe. It's a final, brilliant scream from the dying star, a flare of energy that can be seen across galaxies. Astronomers detect these flashes of light, these cosmic death cries, and it's how we know these violent events are happening. Think about the sheer power involved. A single black hole, an object whose physical size might be smaller than our solar system, can dismantle a star 1,000,000 times the size of Earth. It's the ultimate display of nature's power, a reminder that the laws of physics can be both creative and incredibly destructive. But not all of the star's material is doomed. A portion of that spaghettified stream can be ejected, flung out into space at nearly the speed of light. These are relativistic jets, powerful beams of particles that shoot out from the poles of the black hole. So, as the black hole feeds, it also spews out a fraction of its meal across the cosmos. It's a messy eater. Scientists use powerful telescopes and sophisticated simulations to model these events. By studying the light from tidal disruption events, they can learn about the black hole itself, its mass, its spin, and the extreme environment around it. Each devoured star is a clue, a piece of a puzzle that helps us understand these enigmatic objects. But let's pull back for a moment and consider the implications. Our own galaxy, the Milky Way, has a supermassive black hole at its center, Sagittarius A*. It's about 4 million times the mass of our Sun. And while it's relatively quiet right now, it hasn't always been. Evidence suggests it has feasted on stars in the past. We live in a galaxy with a sleeping monster at its core. The distances are vast, and our solar system is in a safe, stable orbit far from the galactic center. But knowing it's there adds a certain edge to our cosmic perspective, doesn't it? The universe isn't a gentle, peaceful garden. It's a dynamic, and at times, savage place. What would it look like if you could witness this up close? The sky would be distorted. The light from distant stars would bend around the black hole's immense gravity, creating strange arcs and rings, an effect called gravitational lensing. You would see multiple images of the same star, warped and twisted. Reality itself would look broken, and as the star gets torn apart, the accretion disk would light up your view with blinding high-energy radiation X-rays and gamma rays. It would be the most beautiful and the last thing you ever see. There is no surviving a close encounter of this kind. The forces at play would shred any spaceship, any planet, any form of matter. These cosmic curiosities push the boundaries of our imagination. They are real, observable phenomena that sound like they've been lifted straight from science fiction. The universe has a dark side, a collection of forbidden facts and terrifying truths that we are only just beginning to uncover. Black holes are the gatekeepers to this dark cosmos. They challenge our understanding of reality. Inside a black hole, at the singularity, the laws of physics as we know them break down completely. Space and time cease to have meaning. What lies beyond the event horizon? We simply don't know. It's the ultimate mystery, a place from which no information can ever escape. So, the next time you look at the stars, remember what's lurking in the shadows between them. Remember the cosmic monsters that are silently spinning, waiting. The universe is full of wonders, but also full of terrors that remind us of our own fragile place within it all. Does that thought scare you? Or does it excite you? Let me know in the comments below. Thanks for joining me on this journey into the dark heart of the cosmos. If you found these cosmic curiosities as fascinating as I do, make sure to hit that like button and subscribe for more deep dives into the mysteries of our universe. See you in the next one.